Take a single teaspoon down to the surface of a dead star, scoop up one spoonful of its matter, and it would weigh more than every human being on Earth combined. That is not science fiction. That is a confirmed object, cataloged, watched by NASA telescopes right now. And it is only the gentlest thing on this list. Above us, in the real universe, there are magnets that would rip the iron from your blood, explosions louder than every star in a galaxy, and a structure so vast it should not exist under the laws we know. We are about to walk from the strange to the impossible. Subscribe and stay until the final object. It breaks cosmology itself. The first extreme is density. When a massive star dies, its core collapses so violently that protons and electrons are crushed together into neutrons, forming a sphere only about 20 kilometers across, the size of a city, but packing more mass than our sun. NASA's NICER telescope, mounted on the International Space Station since 2017, has measured these objects with atomic precision. A single sugar cube of neutron star material weighs roughly 1 billion tons. Drop it, and it would punch through the Earth like a bullet through fog. The gravity at the surface is 200 billion times stronger than what you feel right now, strong enough to flatten a mountain to the height of a millimeter. And yet, as extreme as this is, some of these dead stars do something that should be physically impossible. They spin faster than any machine ever built by humans. In 1967, a young astronomer named Jocelyn Bell Burnell picked up a signal from the sky that pulsed with such regularity her team briefly labeled it LGM-1, Little Green Men. It was not aliens. It was a neutron star spinning on its axis, sweeping a beam of radio light across Earth like a cosmic lighthouse. We call them pulsars. The fastest known, PSR J174824446 AD, rotates 716 times per second. A city-sized ball of nuclear matter, whipping around so fast its equator moves at nearly a quarter the speed of light. If it spun any faster, it would tear itself apart. Their timing is so precise that NASA studies using them as galactic GPS for future deep space missions. But the true horror is not their speed. It is what happens when a neutron star develops the strongest magnetic field in the known universe. They are called magnetars, and there are only about 30 confirmed in our entire galaxy. Their magnetic fields reach 10 to the 15th Gauss, a quadrillion times stronger than Earth's. To put that in human terms, if a magnetar drifted to the distance of the moon, it would wipe every credit card on the planet, pull the iron out of your bloodstream, and dissolve the atoms of your body into raw quantum foam. On December 27, 2004, a magnetar called SGR 180620, 50,000 light-years away, released a starquake that hit Earth's atmosphere with more energy in 0.2 of a second than the Sun produces in 100,000 years. It briefly ionized our upper atmosphere from halfway across the galaxy, and yet some dead stars are quieter. They do not scream. They crystallize into something we can only describe as a diamond the size of a planet. When a star like our Sun runs out of fuel, it does not explode. It sheds its outer layers and leaves behind a white-hot ember about the size of Earth, a white dwarf. A teaspoon of this material still weighs several tons, but here is where the universe becomes eerie. In 2014, astronomers using NASA's Green Bank telescope identified a white dwarf named PSR J220137, that had cooled for billions of years until its carbon and oxygen interior began to crystallize. Slowly, atom by atom, it turned into a solid crystalline sphere, effectively a diamond, the mass of the Sun. Our own Sun will do this. In roughly 10 billion years, it will die and slowly harden into a cold, dark gem drifting through an empty galaxy. It is beautiful. It is also a warning, because some stars do not get to die this quietly. Some collapse into holes in reality itself. A stellar mass black hole is what happens when a star more than 20 times the mass of the Sun collapses, and nothing, no known force in physics, can stop the fall. All that mass is crushed into a point of infinite density called a singularity. Around it forms an invisible boundary, the event horizon, where the escape velocity exceeds the speed of light. Beyond that line, nothing returns. Not matter, not light, not information. NASA's Chandra X-ray Observatory has identified dozens of these objects in our galaxy alone, betrayed only by the screaming X-rays of gas heated to millions of degrees as it spirals in. If you fell in, an outside observer would see you freeze forever at the edge, red-shifted into silence. But stellar black holes are the small ones. There is one hiding at the center of our own galaxy that dwarfs them by a factor of 1,000,000. It is called Sagittarius A, and it sits 26,000 light-years from Earth at the exact heart of the Milky Way, 4 million times the mass of our Sun, compressed into a region smaller than the orbit of Mercury. In May 2022, the Event Horizon Telescope collaboration released the first direct image of it. A golden ring of superheated plasma wrapped around a perfect circle of darkness. We have been orbiting it unknowingly for the entire history of our species. Every sunrise you have ever seen, every generation before you, has been quietly falling around this thing at 230 kilometers per second. And it is asleep. Sagittarius A is currently quiet, feeding on almost nothing. But somewhere out in the deep universe, monsters of the same species have grown to sizes that defy imagination. TON 618 is a name that should be more famous than it is. It is an ultra-massive black hole discovered in the 1950s, but only weighed in the last 2 decades using spectroscopic data from the Sloan Digital Sky Survey. Its mass is estimated at 66 billion times that of our Sun. Its event horizon is more than 1,300 astronomical units across, so wide that our entire solar system, all the way out past Pluto, would fit inside it more than 40 times. Light itself takes weeks to cross it. If you replaced our Sun with TON 618, its shadow would stretch far beyond the Oort cloud. Nothing in the local universe comes close. And yet, in its youth, this monster was even more terrifying, because when a black hole this large feeds, it becomes the brightest single object in the cosmos. When a supermassive black hole is actively feeding, matter piling up in its accretion disk gets compressed and heated to trillions of degrees. The friction is so violent that a single one of these engines can outshine every star in its host galaxy, 100 billion suns combined. We call them quasars. The brightest known, J05294351, discovered by ESO astronomers in 2024, radiates the light of 500 trillion suns. It is 12 billion light-years away, meaning the light we see now left when the universe was young. Quasars are essentially the birth screams of galaxies. They are so luminous we can see them across nearly the entire observable universe. But even quasars burn for millions of years. There is something else out there that unleashes almost the same energy in a matter of seconds. Gamma-ray bursts were first detected in 1967 by American military satellites looking for Soviet nuclear tests. What they found instead was something the universe was doing to itself. In a few seconds, a GRB can release more energy than our sun will produce in its entire 10 billion-year lifetime. GRB 2219A, detected by NASA's Fermi and Swift telescopes on October 9, 2022, was so powerful it disturbed Earth's upper atmosphere from 2.4 billion light-years away. Astronomers nicknamed it the Boat, the brightest of all time. If a gamma-ray burst went off within a few thousand light-years of Earth and its beam pointed at us, our ozone layer would be stripped in minutes. Some mass extinctions in Earth's fossil record may already have this fingerprint, but even a gamma-ray burst is only the tip of the explosion. Beneath it lies the death of a giant. A regular supernova can briefly outshine its entire galaxy, but hypernovae and their extreme cousins, the superluminous supernovae, take that violence and multiply it by 100. SN 2006 GY, observed by NASA's Chandra and the Keck Observatory in Hawaii, radiated more visible light than any supernova ever recorded, remaining brighter than a galaxy for more than 70 days. These are the deaths of stars over 100 times the mass of our sun. And when they die, they do not just explode. They shred themselves so completely that no remnant may be left, no neutron star, no black hole, just a scar of hot gas expanding forever. It is the loudest way to die that physics allows. And yet, in the same universe that contains these detonations, there is a place so cold, so unnaturally still, that it is colder than empty space itself. The average temperature of the universe left over from the Big Bang is 2.7 degrees above absolute zero. Cold. Almost as cold as it can get. But in 1995, astronomers using the Swedish ESO sub-millimeter telescope in Chile pointed at the Boomerang Nebula, 5,000 light-years away, and measured a temperature of just 1 degree above absolute zero. It is the coldest natural place ever found, colder than the background radiation of the universe itself. The reason is a dying star at its center, blasting gas outward so fast, about 500,000 kilometers per hour, that the expansion cools the cloud below the cosmic floor. It is, quite literally, a natural refrigerator larger than a solar system. But if the Boomerang is the coldest, then somewhere out there, something must be the largest. And it is bigger than you can prepare for. Stephenson 218 is a red hypergiant about 19,000 light-years away in the constellation Scutum. Its radius, according to measurements published in the Astronomy and Astrophysics journal in 2020, is estimated at more than 2,150 times the radius of our Sun. If you placed it where our Sun sits, its surface would engulf Mercury, Venus, Earth, Mars, Jupiter, and reach beyond the orbit of Saturn. A jet plane flying around its equator at cruise speed would take more than 1,000 years to complete one lap. And yet, despite this monstrous size, it is not the heaviest star we know, because in physics, size and mass are two different terrors, and the heaviest star ever confirmed hides in another galaxy entirely, burning through its life at a speed that should be impossible. R136A1 sits inside the Tarantula Nebula in the Large Magellanic Cloud, about 165,000 light-years from Earth. Observations by the Hubble Space Telescope and later refined by the Gemini South Observatory in 2022 estimate its mass at somewhere between 196 and 230 times the mass of our Sun, the most massive star ever confirmed. It burns 9 million times brighter than our sun. It sheds the equivalent of an Earth's mass in stellar wind every month. And because of this monstrous fuel consumption, it will only live a few million years, a cosmic blink, before collapsing, almost certainly, into a black hole or triggering one of those hypernovae we just described. But even the death of R136A1 will look small next to what black holes do while they are still alive. They fire weapons that stretch across galaxies. A relativistic jet is a beam of matter fired from the poles of a feeding black hole at up to 99.99% of the speed of light. The mechanism, still not fully understood, involves twisted magnetic fields anchored just outside the event horizon. What we do know is the scale. The jet from galaxy M87, imaged by the Event Horizon Telescope and the Hubble Space Telescope, extends for over 5,000 light-years, a straight, laser-like line of plasma longer than the distance to most of the stars you can see with your naked eye. Some jets stretch millions of light-years across intergalactic space. They are the largest coherent structures produced by a single object in the cosmos. And yet, and here is where the universe stops making sense, even a jet millions of light-years long is nothing compared to what we are about to see next. In 2013, a team of astronomers led by Istvan Horvath, analyzing the sky positions of gamma-ray bursts detected by NASA's SWIFT satellite, noticed an unnatural clustering across a region of the distant universe. When they mapped it, they found a filament of galaxies stretching approximately 10 billion light-years from end to end. They called it the Hercules Corona Borealis Great Wall. To understand the horror of that number, the observable universe itself is about 93 billion light-years across. This single structure spans more than 10% of it. And according to the cosmological principle, the foundation of modern cosmology, no structure this large should exist. The universe, on the largest scales, is supposed to be smooth and uniform. Hercules Corona Borealis is not just a record. It is a crack in our understanding. It suggests something happened on scales we cannot yet imagine that our theories have not accounted for. We do not know what built it. We may never know. From a spoonful of neutron matter heavier than a mountain to a wall of galaxies large enough to shame the laws of physics, we have walked the edges of what reality permits. And the truth is, every one of these objects is real. Confirmed. Sitting in a NASA or ESA catalog right now, waiting. The universe is not just bigger than we imagine. It is more extreme than our imagination is allowed to be. So tell us in the comments, which of these disturbed you most? The coldest place, the densest object, or the wall that should not exist? Stay small, stay curious, and keep looking up.